Alright, what if we have a probability, but let's say things aren't as they seem. So let's say this example, right? Ruben is playing a matching game with these cards. He turns the cards over, then shuffles them. He takes a card, keeps it, then takes a second card. If the cards are different, he wins the game. Complete the tree diagram showing the probabilities of each card picked in the game, right? There's only circles and squares, right? If there are 4 circles, right, and there's 9 in total, then obviously this is going to be 5/9, right? Standard stuff. The issue comes with the second round. You see, if he picks a circle, it means now there is 1 less circle to deal with. So how many circles are there? There's 1, 2, 3. And how many cards are there? 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 3/8. However, if you look at the number of squares, the number of squares hasn't changed. So this will still be 5/9. Okay? 5/8, excuse me. There's still 5 squares, but now there's 8 cards in total. So our probability is 5/8. And likewise, if we go on the other way, we take a square, we have to take away 1 square out of the equation, which means now there are 4 squares in total and 8 cards. And finally, there are still 4 circles because the circles haven't moved. So that is how we plot a tree diagram for combined probability. Are you finding this video helpful? Make sure you subscribe so you never miss a video from me. Now let's look at how we use it in practice. Here there are 9 cards, each has a shape on it. In a game, the cards are turned over so that the shapes are hidden. The cards are then mixed up. Katie turns over 2 cards at random, so work out the probability that they have different shapes on them. Okay. So for this one, it is going to be a tree diagram. So let's draw a tree diagram. We have 1 like here. Okay, this one's a triple one. Just a bit tricky, but hey, the general premise is the same. We got 2 circles. So if we call this one a circle, this is going to be 2/9. If this one's triangle, then it's going to be 3/9. And then if this one's a square, it's going to be 4/9, okay? Let's look at the circle first. If we take away one of those circles, there's only going to be a 1 in 8 chance, because now there's 8, of it being a circle. But the other probabilities, at least the numerator, stays exactly the same. So this will be 3/8 and this will be 4/8. Same thing with the middle. If we take away a triangle, right, the number of triangles is different. So this is going to be 2/8, but this and this are still going to be 2 and 8 and 4. Is it 4 and 8? No, wait, other way around. Sorry, this is 4 and 8. This is 2 and 8. Okay, for circles, and this is a square. And as you would probably guess, for this last one, we take away a square. This is going to be 3/8. Okay, this is going to be 3/8 as well, because there's only 3 triangles. And this is going to be 2/8. Okay, now to find the probabilities of it being the same card. Oh, sorry. If they're different, right? Yeah, they have to be different. So, if they have to be different, what we can do is we can, if we want to, work out all of these probabilities through these branches, right? But there's actually a better way of doing it. What we can do is work out the probabilities of each of them being the same. So the probability of circle is going to be 2/9 times 1/8. right? And if we plug that into our calculators, we get 2 in 72. The probability of... Actually, I'm just going to do this in different colours. Same colour. Probability of triangle is going to be 3/9 times 2/8, which is equal to 6/72. And finally, the probability of square, that's just going to be 4/9 times 3/8, which is 12/72. Let's add them up, which will be 18/72. No, 20/72, excuse me. Okay. And then the probability of two different is just going to be 1 minus 20/72, which is 52/72. If you want to simplify that, you can simplify it and it will become 13/18. And that is our final answer. Do you guys need some more help? Well, join my Discord server and send me whatever questions you want down below for fast responses guaranteed. Now let's look at this one. It's a bit more tricky. Here, there are 10 pens in a box. There are X number of red pens and all the others are blue. Jack takes a random pen out of the box. So find an expression in terms of X for the probability that he takes one pen of each color. Well, the first thing we need to do is draw a diagram. I'm just gonna do that. So that's one, that's a tree, and that's a tree. Sure. How many pens are there in total? There are 10 pens. So if this side is red, then let me get my red pen out. This will be X over 10. Of course it is, because there are X red pens, and there are 10 in total, so X over 10. So what's the probability of me getting another red pen? Well, all we need to do is minus top and bottom from 1. So this is going to be X minus 1, because we're removing a red pen out of the box. And this is going to be 9. Likewise for the blue, right? This is going to be 10 minus X over 9, isn't it? If this is X, then this has to be 10 minus X over 10. And if we take out a red pen, a blue pen, then it means that the amount of pens that I have in the box, blue pens, is going to be 9 minus X over 9. And the number of reds stays the same. So how can we find numbers? Well, what's the probability that they're going to be different? Well, we can either take this path or this path. So the probability of blue, red, that's just going to be X over 10 times 10 minus X over 9 plus 10 minus X over 10 times X over 9. Okay? So all we're doing is we're multiplying these two and these two. Let's simplify it now. So this is the same as X times 10 minus X over 90 plus X times 10 minus X over 90. Well, given that these two are the same, right? we can leave that as 2x times 10 minus x over 90. And we can cancel out the 2's on each side. So we're left with x times 10 minus x all over 45. And that is our final answer. It's exactly the same as what we've done before, only this time it's with algebra. And guys, don't let the algebra throw you off. If you know how it works with real numbers, you can do it with the algebra. Thank you guys for watching. If you guys want to pass your exams with flying colours, drop me an email and we can organise a meeting and a quote to get tutored by me. Keep on learning as you have no idea what you're capable of doing.